Alright, gang, we're back. Let's talk about our exponent rules. Alright, so let's review what a monomial is. Mono means one, right? So this is one term. This is one term. A monomial is one term. Now, let's review because a term is a number, a variable, or a combination of a number and a variable. So some examples of terms, 34xy. Okay, that's a single term. 7a squared b, that's a single term. Terms are separated by operation symbols, right? So this would be two different terms. It's separated by this operation symbol. A term has a base and it has an exponent. Okay, it has a base and it has an exponent. Now these are going to be very important to know because when we start talking about the different rules that we have with exponents, that depends on your base. So let's look at our first rule for exponents. We have a product of powers. Now notice that if we are multiplying two numbers with the same base, and again the base is the number, not raised to the exponent, excuse me. Okay, so if they have the same base, then we can add the exponents. So if we look here, my base in this first example is 5. Well, this is the same base, so this is 5 squared and then 5 raised to the 6. This is 5 times itself twice. This is 5 times itself 6 times. So if they have the same base, we then just add the exponents. Well, 2 plus 6 is 8. So my answer is 5 raised to the 8th power. 5 raised to the 8th power. Okay, so what that is saying is that's 5 times itself. 5 times itself 8 times. So this would be 5 times 5, 8 times. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. All right, and that is 390, excuse me, 625. All right, so now let's look at a variable. Okay, this is the same variable. It's the same base. It doesn't matter if it's a number or a variable. It doesn't matter. It's still a base. And that is the same base. Those are multiplied together. So if it's the same base multiplied together, we just then add the exponents. Now, be very, very careful because this y is raised to the first power. So understood 1, we just don't write it. So we have 4 plus 3 plus 1. That would be y to the 8th. Now again, what that's telling me is that's y times itself 8 times. That's what that means. Those are equivalent. Alright, now what about this? Okay, this my base is y. So we know we're going to add the exponents. Now again, this is y to the first power. So we have y. 5 and 1 is y to the 6th. But now we're going to multiply our coefficients because these two are multiplied together. This term is multiplied by this term. So 7 times 6 is 42, right? So my coefficient in front is 42 y to the 6th power. What this means is this is 7 times y to the 5th. And that's times 6 y. Well, 7 times 6 is 42, and then we have 1, 2, 3, 4, 5, 6, y to the 6th. Looking at the next one, we've got negative 3 times 5. Okay, so if I wanted to expand this out, I have negative 3 times x, and then times y 7 times. Alright, so that's what that parentheses is, and that's multiplied by 5xy to the 6th. So 5x y to the 6th. Alright, so again, we're going to multiply numbers. So negative 3 times 5 is negative 15. We have an x and another x, so we have x to the 3rd. If I wanted to just look here, I've got x squared and then an x to the first power, so 2 plus 1 is 3. I've got y to the 7th, y to the 6th. I'm going to add the 7 and the 6, and I get y to the 13. If I look here, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's where I got that from. Alright, moving on to quotients. Okay, moving on to quotients. Okay, now if they're divided, so right here they were multiplied and we added. Well, if they're divided, we're going to do the opposite, which would be to subtract exponents. So we're looking at number 1. It's the same base. It's a base of y. So this is 6 divided by 1. So this would be y to the 6th, which looks like this, over y to the 1st. Well, this y divided by this y, those cancel out, and we're left with y to the 5th on top. I could just say 6 minus 1 is 5. That fraction bar tells me to subtract exponents. Same thing here, right? I've got a number. The base is 6. 13 minus 2 is 6 to the 11th. 6 to the 11th. Now, if you wanted to go ahead and make that a number, 6 to the 11th is equal to 362797056. Yeah, I just did that in my head. Just kidding. All right, look in here. Okay, I can reduce fractions if possible because 10 divided by 15, they're both divisible by 5. So this then becomes 2 over 3. Now let's look at our variables. A and A, so there's the same base. I can subtract exponents. 7 minus 5 is A to the second. Now understand, the bigger exponent is where the variable will stay. Right? So 7 minus 5, the bigger exponent is 7. So A squared is in the numerator. Okay, if it was opposite, if this was A to the 5th over A to the 7th, well, 5 minus 7 is negative 2. So you know that the 2 is going to be in the denominator because the bigger number is right there. So take these two numbers and subtract. Wherever the bigger exponent is where the number will stay. So here, the bigger exponent is in the numerator. That's why the A squared is in the numerator. This would be A squared in the denominator because 7 minus 5 is 2. But again, the bigger number is in the denominator, so it would look like that. All right, let's continue here. B to the 9th minus B to the 9th. Well, 9 minus 9 is 0, so those cancel out, and that's my answer. All right, any non-zero exponent, right? Any zero exponent. So A raised to the 0, anything raised to the 0 is 1. This is easy. Okay, this is easy. All right, so if we're looking right here, this thing raised to the 0 power is just 1. This thing raised to the 0 power is 1, but this is plus 5. Well, 1 plus 5 is 6. So anything raised to the 0 power is 1. Anything raised to the 0 power is 1. Hold on. I almost screwed this up. So anything raised to the 0 power is 1. So x raised to the 0 power is 1, but that's 1 times 8 plus 5. Sorry. So this is 8 plus 5. That's going to be equal to 13. This is negative 3x raised to the 0 power. So you'd have negative 3x raised to the 0 plus 7 raised to the 0. All right, let's go back and let's look at this. So I've got negative 3x raised to the 0. That's 1 plus 7 raised to the 0, that's 1. This equals 2, not 1, you dummy. Sorry about that. All right, negative exponents. All you have to do if it's a negative exponent is change what level it's on, right? So it's not happy where it's at, so switch it, move it. If it's in the numerator, move it to the denominator. If it's in the denominator, move it to the numerator. So what I'm asking you to do is to make this a fraction. Well, a 2 raised to the negative 3, any whole number is over 1, correct? Okay, so all I'm asking you to do is to take this, and since that's a negative exponent, is move that puppy to the denominator. When you do that, it becomes positive. So the answer here is 1 over 2 raised to the 3rd power. Well, 2 raised to the 3rd power is 8, so this equals 1 over 8. Same thing here. I've got negative 3 raised to the negative 3rd power. Again, all I'm going to do, this is over 1. So all I'm going to do is I'm going to take this, and since it's a negative exponent, I'm going to move it to the denominator, and it's going to become positive. So I've got 1 over negative 3 raised to the 3rd power. Well, negative 3 raised to the 3rd power is me saying negative 3 times negative 3 times negative 3. So that equals negative 1 over 27. Okay, or equals 1 over negative 27. Those mean the exact same thing. So if it's a negative exponent, you just change what level it's on. If it was a negative exponent in the denominator, guess what? Move it to the numerator. Easy breezy. All right, let's look at a little bit harder stuff. So let's look at a power raised to a power. So there's a huge difference between this, a power that's raised to a power, and when we were looking at the first one, which we were just multiplying. Here we have the whole parentheses raised to a power. Right? So I've got x raised to the 2nd power, and that is raised to the 8th power. So what this is saying is that I've got x squared 8 times. Okay, and yeah, etc., etc., etc. So I've got x squared, which is x times x, times x times x, times x times x, times x times x, all the way 8 times. So you're going to take this 2 and multiply it by 8, and we get x raised to the 16th power. Same thing here. We got y raised to the negative 3. We're going to take these and multiply it because we have a power that's then raised to a power. So negative 3 times negative 4 is going to be positive 12. So this is y raised to the positive 12. Okay, well, let's take it a step further. What if I have a number and a variable inside the parentheses? Well, then we're going to distribute, right? This whole thing is raised to the m power. So let's take that and let's distribute it into our numbers and variables inside the parentheses. All right, so I'm going to rewrite this. I've got y. Sorry, that's not a y. That's a 4. I've got 4x cubed. I'm going to write it as y to the first because that y is y to the first. Z is z to the first. And that whole thing is raised to the 3rd power. Now, why did I write the 1s? Because we're going to take that 1 and then multiply it by that 3 because we're raising a power to a power. So I've got 4 raised to the 3rd power. I've got x raised to the 3rd, raised to the 3rd. So 3 times 3 is 9, so I've got x to the 9th. Y to the 1st, raised to the 3rd, so y to the 3rd power. 1 times 3 is 3, and same thing with z. Right? So there is my answer. Now if you want to take it a step further, again, we can take this 4, raise it to the 3rd power. So 4 times 4 is 16. And then times another 4. There's your answer. Same thing here, right? We're going to take this negative 2, but it's a negative exponent. It's a negative exponent. So what I'm going to do is I'm going to take this puppy, and I know this is over 1. If any negative exponent, I'm going to change what level it's on and make it positive. So I'm going to say this is the same thing as saying 1 over 7xy to the negative 2. And then that negative 2 now is a positive 2 because I changed what level it's on. Now let's take this and let's distribute this into our parentheses. I've got 1 over 7 squared, x to the first times 2, so x squared, y to the negative 2 times 2 is y to the negative 4. Now we're not done. You cannot leave negative exponents. So this y to the negative 4, since it's already in the denominator, to make it positive, I need to move it to the numerator. I need to change what level it's on. So my answer is y to the 4th. When I change it and put it in the numerator, it becomes positive. That's over 7 squared, which is 49, x squared. All right, same thing here. This is over 1. I'm going to move it to the denominator. So I've got 1 over 6x to the negative 6, y to the negative 7, z to the 0. When I put that in the denominator, it becomes a positive 2. So I've got 1 over 6 squared. X to the negative 12, because negative 6 times 2 is negative 12. Negative 14, negative 7 times 2 is negative 14. And then z to the 0 times 2 is still z to the 0. And again, we know anything raised to the 0 is just 1. So we don't even have to write that, because 1 is just 1. Now let's look at our numbers here. So this 6 squared is 36. This x to the 12th needs to go to the numerator to make it positive. So this is x to the 12th in the numerator. This y to the negative 14 also needs to go to the numerator to make it positive. So there's your answer. All right, a power of a quotient, right? So if I have a fraction, all I'm saying is that both of those are squared, right? So this is 3 squared over 5 squared. 3 squared is 9, 5 squared is 25. Same thing here. This is 2 squared. This is a to the 5th. So this is 2 squared. So power raised to a power. So a to the 5th raised to the 2nd power. That's a to the 10th. Over b to the 7th raised to the 2nd power is b to the 14th. So we could say that this is 2 squared. 2 squared is 4. A to the 10th over b to the 14th. Now those are not the same base, so you cannot subtract those. So there's your answer. Same thing here. I've got 3 raised to the 3rd power. I've got a to the negative 4 raised to the third is a to the negative 12th over b to the 7th raised to the third, which is b to the 21st. Now, this is a negative exponent. We need to move that to the denominator. 3 raised to the third power is 27. 3 times 3 is 9. 9 times 3 is 27. So it's 27 over b to the 21st, a to the 12th. All right, let's look here. I'm going to distribute this negative 6 into my parentheses. So I've got a to the negative 2 to the negative 6. So negative 2 times negative 6 is a to the positive 12. Negative 5 times negative 6 is the positive 30 over positive 66. Okay, now none of these are like terms, so we cannot cancel anything out. There's your answer.